Hello, my name is Pieter Dullebelle, and in this video we'll present our survey on fairness metrics for language models and results of our comparisons, as well as a Python package that contains most of these metrics. So, imagine you've created a language model, like a new BERT variant, and you want to test it if it's fair or not. What do? You look at the literature and perfect, a paper. Another one. Oh. All these papers are different methods, and although some are similar, they are not exactly the same. So, which one do you use? And what do these metrics measure exactly? For that, we first need to define what we mean by fairness. Language models, like BERT, are typically trained in two stages, so also on two datasets. The pre-training step, typically on larger unlabeled datasets, and then the fine-tuning step, with smaller but labeled corpora. We typically use an already pre-trained model, like BERT-based, to do some other downstream tasks, such as sentiment analysis. Each training step and its datasets can introduce bias, which we refer to as intrinsic and extrinsic bias. In our paper, we focus on the intrinsic biases in pre-trained models. Here, we typically see representational harms, like stereotypical professions. In this example, BERT is asked to fill in the mask in the sentence "Mask is a nurse." She is the most likely token by a long shot, and then he, and then followed by a long tail of mostly female names. Before we dive into the metrics, let's first take a look at traditional word embeddings like Word2Vec. Here are two fairly well-known papers that measure biases. The Word Embedding Association Test, or WEAT for short, by Kaliskan, and the Bias Subspaces by Buluk-Basi. The methods are different, but for this video it's enough to know that both measure associations between groups of words. Let's look at WEAT as an example. This metric needs a set of target words, like man and woman, and attribute words, like doctor and nurse. WEAT then measures how well these target and attributes are similar, with cosine distance in the case of word embeddings. However, contextual word embeddings or language models such as BERT work differently. These models do not give a single embedding, but different embeddings depending on the context of a word. After all, a word can have different meanings in different contexts. Because language models are trained with sentences and thus require that context, it's best to also provide this. For this, we use templates. These templates have one or two slots where we can add our target and attribute words. Alright, this is a very high-level overview of existing metrics for language models. And what I've described is mostly the sentence embedding association test, SEAT, and other WEAT derivatives. There are other metrics that are a bit different. For those, I would recommend reading the paper. But this gives us enough intuition to understand the analysis that we did. So, we looked at different templates and tested if they measured different levels of bias. And they did. Some templates resulted in higher SEAT scores. Thus, not all templates were consistent with each other, which we visualized here with correlation analysis. This is not great, because the choices of templates can really change the conclusion if a model is biased or not. The same is true for how we obtain the embeddings from the language model, which we can either get from the class token or from the token of interest, either with mean pooling if there are multiple, or just we take the first token. Here we also see that these choices affect results and thus can affect the conclusion as well. Finally, we also tested if the results of different metrics correlate if we try them on different language models. Some metrics, like the three WEAT-based ones on the top, do correlate, but others do not. Since the different choices for templates and embeddings already affect the bias measures, this is not entirely surprising, but still. This makes it difficult to measure intrinsic biases. So, what can we do? On the one hand, we advise to look at bias evaluations in downstream tasks. After all, here are the actual decisions being made. On the other hand, we think it's best to use multiple metrics for intrinsic biases to get a broader picture, but know that the predictions might be different. Alright, so that's it for this video. If you want to know more, check out the paper and feel free to reach out to me on Twitter or email.